This is Dr. Mobeen Sayed. Welcome to one more episode of Long Story Short with DrBeen from the FLCCC platform. The discussion today is intriguing, very interesting. It is about the brain health, especially the waste removal from the brain, which if the waste is not removed correctly, then there is a chance of Alzheimer's disease and dementias as well. This article that I'm going to show you has actually aggregated many murine studies, animal studies, because it is difficult to have Alzheimer's patients and then take their brain tissues. That's just not possible. So most of these studies are in animals. In this study, in this article, the authors have collected various lifestyle choices that would help us keep our brain healthy as we age and as we have factors around us that would cause or progress dementias or Alzheimer's or just cognitive decline or memory decline or word finding, etc., which nowadays, because of long COVID or vaccine injury, is also becoming more prevalent. I'm only going to take one part of this paper, that is intermittent fasting, and discuss that. The paper talks about fish oil, the paper talks about exercise, alcohol use or less use, etc. So there are many lifestyle choices in here. I just want to focus on one. We'll discuss the other parts separately. I would also recommend that you look at this paper as well. So let's start. So first, this is the FLCCC site. Interestingly, this paper has fish oil in it as well. And look right here, power supplement fish oil. So this is FLCCC site. There are protocol here. There is a lot of information here, lots of lectures here. My lectures are here as well. Then this is the article, The Sleeping Brain, Harnessing the Power of Glymphatic System Through Lifestyle Choices. Beautiful, exhaustive paper. If I can show you quickly how well it is. This is the PDF of the paper, and I have, of course, read it multiple times, highlighted it. I highlight things to then remember them. And this is a paper that I'm going to discuss, but just one part of it. So to understand this, the basic summary, what are we going to talk about? Intermittent fasting and its association with brain health, or more correctly, its association with waste product removal from brain, which would allow a reduction in the chances of dementias and cognitive declines and memory declines, or at least slowing down of that. At least that is what is proved from the animal studies. The keywords to look for, there are many new concepts that we'll go through. I'm going to go very slow, concept by concept, because it is important to capture these concepts. You can then apply the same concepts to other parts of this article as well. So we'll talk about what is a glymphatic system, not lymphatic. Glymphatic system is a system for the brain. What is paravascular space? This is also perivascular space. Then what are astrocytes, glial cells, aquaporine 4 channels, foot processes, blood-brain barrier, blood-CSF barrier, choroidal plexus, etc. So lots of things that we'll discuss. But I think you will enjoy it, that I will not leave you behind. We'll discuss this together. So summary of the message today. Intermittent fasting helps improve the glymphatic system circulation. So imagine the lymphatics of the brain, which results in healthy brain tissue, potentially reducing the risk of dementia and improving cognition, memory, and executive functions. In my opinion, this is important nowadays for vaccine injury and long COVID. Actually, even if somebody doesn't think long COVID and have had COVID, they should have these exercises or these supplements and lifestyle choices. Going to the mechanisms. This is the key diagram for this whole discussion. In our brain, of course, we need the blood supply, correct? So we have blood vessels, carotids that come into the brain area, that tissue, then they divide into smaller arteries, which penetrate deeper into the brain tissue itself, and finally they become fine capillaries. So here we have a capillary that is in front of us. Brain's capillaries take part in blood-brain barrier. And we are not exactly talking about the blood-brain barrier today. I want to talk about a different kind of a flow. But for completion's sake, the brain's capillaries do not allow fluids or nutrients and other substances to just simply willy-nilly move out. Imagine this is all brain tissue. The fluids are not just allowed to come out. Actually, the cells that make up the walls of the capillaries, these cells are connected with each other through what we say tight junctions. So these cells, if this is one cell and here is another cell, usually in our body, the cells have slight distance between them, which is called a gap junction, through which things can move. But in these capillaries, these are welded together. They're bound together. This is called a tight junction. So nothing is allowed to move from one side to the other side. So in the case of capillaries, nothing is allowed to move from inside to outside. So then your question will become that, all right, if nothing is allowed to move out, then how does the brain get nutrients? And how do the waste products go back? So what happens is these tight junctions have specialized receptors or specialized channels through which only selective things are moved out. So our brain's blood vascular system decides what is it that will enter the brain. Now these capillaries are in turn further surrounded by another set of cells, these green ones over here, which are called pericytes. So pericytes also have junctions in them or channels in them to continue to allow the movement of substances, selective substances, chosen substances. Then if you see down here first, imagine in the center is this capillary. Around the capillary is this green sleeve, just like if you are wearing a shirt on an arm. These are pericytes. Then there is some space. Imagine if you're also wearing a jacket. Then there is a space from the shirt to the jacket's collar, and this blue one is the jacket's collar. The important thing is the space between the pericyte and this jacket's collar is called perivascular space or paravascular space. This is not the structure that is present in the rest of the body. This is a specialized structure in the brain. Now, these blue cells, they are actually, the cell is here, the cell is here. These are called astrocytes because they look like stars under the microscope. So they are called astrocytes. They have many, many tiny branches coming out of them. These branches then dilate into big structures that are called foot processes. And these foot processes make a collar around the pericytes with some space between the pericyte and that foot process. They make a tunnel in which the capillary is present. And they cover, so I have not made them here, but they cover the whole vascular system. So anything that comes out of the blood vessel or the capillary and then pericyte would still be within the tunnel made by the astrocytes. These guys are called astrocytes. And these are called their foot processes. And today's whole discussion is going to be about the astrocytes and their foot processes. So just become friends with these blue things. Now, in these blue things, so you'll be right if you said that fine, we've gotten the fluids or substances selectively extruded from the capillaries, and now they are in this perivascular space. If we still do not allow them to come out of this space, then how would the brain tissue, which is all over here, how would that tissue receive nutrition? So then there are specialized channels in this layer as well. And one of those channel types is called aquaporin 4. Aquaporin 4. Aqua standing for water. Porin meaning it's a protein that makes a pore. It's a channel, it's a pore. And then type 4. There are actually many aquaporins, 1, 2, 3, 4 to 11 or 12. And then even aquaporin 4 themselves are two types, M1 and M23. One is a long form and one is a short form or isoforms. So this channel eventually allows what will come out of this pericyte space into the brain tissue. So I think you can realize that if aquaporin 4s are for some reason incorrectly functioning, then we'll have a problem, right? So let's move to the second concept. The second concept is this, that imagine for a second, I am a neuron. I am a neuron, just one single neuron. And I'm sitting in this room, and imagine this room is brain tissue space. The neurons are so highly privileged, and I'm not using the medical privileged, which is they are immunologically privileged as well. But I'm talking about societal privilege. They're so privileged that they need very selective substances to come to them. Plus, when they are functioning, They need a continuous flow of water in which these are immersed, the neurons, and are continuously washed. So imagine the requirement from the neurons that, hey, when we are working or even when we are resting, we need continuously to be washed. So that means if I am a neuron, then this room should have some little pipes here through which water is just continuously flowing in and washing me and then flowing out. These pipes are these aquaporins. So the important concept here, second one, is this. This perivascular space, which all the perivascular spaces collectively are called paravascular spaces. This perivascular space contains cerebrospinal fluid or CSF. Now for ages, the scientists thought that the function of the CSF, because CSF is, so if you think about it, brain has multiple layers on it. There is the layer that is very tightly adherent to brain tissue, that is called pia matter. Then above that is an arachnoid matter. Then above that is dura matter. Dura matter is stuck with the bone. Arachnoid matter is kind of floating between them. And then there is fluid between the pia matter and arachnoid matter, and that is CSF. The fluid around the brain tissue allows the brain to kind of float in our skull. Think about it, brain is such a fragile tissue, delicate like egg. If you let it move about in our skull, the bones would just cause contusion and bruising and just kill it. So we have a fluid padding it so that number one, the weight is less, and number two, it floats around and it doesn't hit the bones. So plus it acts to clean out the bigger particles in the brain system. But for a long time, scientists used to think that this CSF gets absorbed back into the venous side and then goes out of the brain tissue. But CSF production is about 500 milliliter every day. And the problem for scientists was thinking that 500 milliliter of CSF is absorbed in the venous system every day without any active pickup was a very difficult thing. The diffusion was a slow process, and that just did not make sense. So there was a Danish scientist who in 2012 imaged the brain's lymphatic systems or CSF's circulation and found out that CSF actually continues in these paravascular spaces around the blood vessels in the sleeve, and then it actually mixes with whatever is coming out of the blood system, and then it mixes, these two fluids mix here, and then they come out of aquaporins in this brain tissue. So here what comes out in the brain, I've made it in two parts. One is these purple things, that is CSF, and the other one are red things. These are the substances coming from the blood. Then what happens? If it comes in, it needs to get out as well, right? So look at this one. Imagine this is the brain tissue. This is me sitting in this room. The fluids are coming out. They're coming through the blood system. They're coming in the CSF spaces. Then they're coming out through the aquaporin and they are washing this area. Then eventually on the venous side is where the blood will be returning back towards heart. On the venous side, we have a similar structure. We have astrocytes making a sleeve around the veins as well. And they also have aquaporin 4s over there. So the fluids that come out, they wash these neurons, and then these fluids get moved in, and a lot of big particles get stuck in this perivascular space, and then they just travel through that space and become part of lymphatics, and they drain in the deep cervical lymph nodes. So the deep cervical lymph nodes, where are they? They're under the sternocleidomastoid muscle. So if you turn your head and this muscle, the beauty muscle that becomes apparent, that is sternocleidomastoid. Deeper to that are the deep cervical lymph nodes. This is why patients of long COVID neurological symptoms or vaccine injury neurological symptoms, they feel better when they milk this area downwards, because they cause the cerebrospinal fluid, or they cause the lymphatics to move, which causes this lymphatic substance to move out, which sucks more lymphatic fluids inwards, which moves the whole system and starts cleaning the brain or brain tissue. So when the fluids are getting back towards the venous system, part of the fluids would get trapped, which have bigger particles in the perivascular space. These fluid bigger particles cannot get into the blood vessels. So there will be a venous flow, which will have more refined particles going back in it and carbon dioxide going back in it. and then the bigger particles with fluid will just flow through perivascular system to finally reach lymphatic system. From lymphatics, they would then eventually go back into the veins and heart, and then they would start circulating again. This whole structure of paravascular fluid coming out, then paravascular fluid going back into the paravascular fluid and going out, independent of the blood circulation, is called glymphatic system. The importance of the glymphatic system is continuous washing, continuous provision of the flow, a convection current of the flow that goes through the brain, especially when we are sleeping. When we are in the wakeful state, when we are working like you and me right now, this system is 90% less active. But when we sleep and when we are especially in the N3 phase of the sleep, then this becomes 90% more active. Plus, if we intermittent fast, so I'm going to go there first. We'll talk about sleep later on. Although this paper, you can see the title, it says Sleeping Brain. It is about the sleep. So we'll go to the sleep as well, but I want to connect it to intermittent fasting because at FLCCC, we've been discussing intermittent fasting for some time. Okay, so I hope this is clear that how this glymphatic systems work. Now, next important concept to grab is this. These are astrocytes. So these cells that are making up these sleeves around the vascular system, these little guys, I've made them just independently. So this is an astrocyte's body, and it has many little branches, and then branches have these foot processes on them. And these black ones are the aquaporin channels. Aquaporin channels, remember this whole thing is one cell. Aquaporin channels usually are present only on the foot processes. That means they're present around the blood vessels, right? Because the foot processes are surrounding the blood vessel. So if the aquaporin channels are here, then they are around the blood vessel. Imagine if there is a channel here on the body of the astrocyte. There is no use for that because this body is not in contact with the fluid space. So you can think, I believe, that the channels are needed on the foot process. They're not needed anywhere else. So here, this is a good astrocyte. Majority of the channels are on the foot processes and taking part in the movement of the CSF and blood substances that we've taken out. Look at this astrocyte. In this astrocyte, you see that there are fewer channels on the foot processes and a lot of channels are on the body of the astrocyte. They both have equal number of channels, but here the channels are on the body and here the channels are on the foot process. The channels on the foot process are good. The channels on the body are useless. But they both astrocytes are feeling equally proud that, hey, we have a good number of channels. But this one is not going to function very well because what's happening is this one, let's say the bad one, is saying, I don't have channels here on my foot process, but I'll have a lot of channel on my head. Okay, then how are you going to move the fluids out of this foot process area? That will be the problem. So please realize this concept that this is called polarity of the aquaporin channels. Polarity simply means they are polar, they are on the poles. If you have the astrocyte divided in two poles, body and feet, then they are polarized, they are on the feet. Here, the channels have lost polarity. They are everywhere on this cell. They are on its head and its face and its trunk and on its feet. Polarized astrocytes are good. Not polarized astrocytes are bad. Second concept here as well. The M1 type of aquaporins should be less. M23 type should be more. So whenever M1 type increase, we will have an obstruction in the flow. So these two concepts. Now, final concept for which I did all this discussion. That concept is the following. When we do intermittent fasting, then our liver, of course, starts breaking down lipids. And in this particular paper, the intermittent fasting that they did was animals that were starved for a day and then fed for a day. And so this was a 24 hours fast, alternate days. So during this time, when the animal was fasting, their liver would start breaking down lipids. And as part of lipid oxidation, the liver will make beta hydroxybutarate, one type of breakdown product. This beta hydroxybutarate will go from the liver all the way to the brain. Once it goes to the brain, it enters various brain cells and enters their nucleus. And here I've made a very tiny piece of nuclear structure. In the nucleus, we have DNA. These red little strings are actually one string of DNA. Imagine the DNA being a very long rope but microscopically thin. If you just leave it in the nucleus like a little piece of rope sitting there, it's going to become all tangled and jumbled because cells are moving about all the time. This is like if you have a long thread of yarn and you just put that on the floor and keep moving it about, soon it will become all tangled up. So we cannot afford to have a tangled DNA because we very often come in and open up the genes of the DNA, work with them, and then close them. So how do we do that? We have histones. These are proteins. So here is a protein. You can actually think about these as one wooden stick and some wooden balls or metallic balls. So this wooden stick has 2 holes in it. So of course they are not wooden, they are proteins. We thread the DNA through one hole. Then there are 8 balls called histones as well. And then the DNA is tightly wound around those balls. Just like we have the yarn wound around a ball-like structure. Then the other end is taken out and it is once again threaded through this protein and taken out. Then if you tighten this, then this becomes a tight DNA, an organized DNA piece. Now the question is, how would this thread stay stuck to these balls? We actually can acetylate. We can create magnetic forces on the ball so they attract the DNA thread to them and keep it stuck to it. So of course, then whenever we want this gene to open up and create an mRNA, then we have to reduce the magnetic forces of these balls so that the thread can separate from it and the enzymes can work on this DNA to express the genes or copy them into mRNA. That enzyme are acetylation enzymes. This hydroxybutarate comes in and prevents the acetylation of the histones that are responsible for M1 gene of aquaporin. So the result of that is M23 genes are expressing more, but M1 genes are expressing less. That means good kind of aquaporins are increased. So that is one effect of intermittent fasting. And I can connect that to lipids as well. I can then connect that to fish oils. Fish oils do the same thing. And just for your pleasure, I'm going to show you this. I really loved it on the FLCCC. If you see here, fish oil. So back here, fish oil does the same thing, omega-3s. Now, once this hydroxybutarate is produced, now we are ready to understand the whole mechanism. Imagine this is a brain in which aquaporins aren't working correctly. Why are they not working correctly? Maybe the brain has gotten some debris because of, let's say, vaccine injury and there is inflammation and the fluids are not moving correctly, or there is a long COVID, or there is other congestive situations of the brain, inflammatory state of the brain. It happens with aging as well. It happens if we exercise less. It happens if we are drinking more alcohol and so on. So what happens is, this fluid that was flowing through the brain tissue, its job was to remove the debris, which includes the beta plaques, amyloid plaques, and the tau proteins. These are the proteins that are responsible or are observed in dementia and Alzheimer's, right? So the fluid current's role is to wash them away. However, if the aquaporins are not working correctly, then these piles of these plaques, proteins, would start piling up in the brain tissue. The problem is that when they start piling up, that causes even more problem with the flow because number one, they start obstructing whatever less remaining aquaporin channels are. Number two, whatever channels are working and producing fluid, that fluid finds it really difficult to move through this mud that is present there. And this becomes a positive feedback loop and we keep becoming bad and bad. Our cognitive decline continues to increase. Alzheimer continues to increase. Dementia continues to increase. So what do we need? If you look at these astrocytes, they are bad astrocytes. They have the aquaporin channels on their body and very few on the astrocytes. And they are, we would call it unpolarized aquaporins. If we can polarize them, that means if we can produce more channels on the food processes, that would allow more CSF to come into the interstitial fluid area and wash away these little things. So what you do is you do intermittent fasting. Intermittent fasting will cause hydroxybutarate, which will then change the polarity and cause the aquaporins to be moved onto the foot processes, plus M23 type produced more than M1 that are healthy aquaporins on the foot processes. As soon as that happens, the fluid starts flowing freely, washing away the plaques that are forming and the waste substances that are accumulating and helping brain back towards health. What a wonderful mechanism. And this is intermittent fasting. We have discussed intermittent fasting in the context of brain in other ways as well. For example, hippocampal neurons. I've done that discussion before. Please look at that. This is another mechanism of intermittent fasting, helping to keep brain sharp and to reduce the chances of decline. So this is the discussion. I hope you liked it. I would love if you look at this paper as well. I would do some more discussions on this paper, for example, with the omega-3 and the exercise and other life choices that they have mentioned, better sleep, most importantly, melatonin, most importantly, less noradrenaline, less stress. So I would discuss them in the future as well. Thank you very much. See you next time.